All right, so one of the first things we're going to learn how to do in this new unit is going to be a little complicated, but it's totally doable, and I'm going to show you how to do it. And it is solving system of equations for not just two variables, but three variables. So enter the z variable. So here's the deal. What you're going to do is you're going to start off by looking at, there's always going to be three equations, and you're going to start by kind of making sure that they're all in the same order. So it's very helpful to always have x, then y, then z equals, and then a number. And then what I like to do is I like to label these. So this is equation 1, equation 2, and equation 3. So the way this works is you're going to use elimination to create two new equations with only two variables so you can set up a problem that you actually already know how to solve. So yesterday in the attendance task, if you already kind of reviewed how to do that, that's really the only skills you need to do one of these problems. So the first step, what you're going to do is you're going to pick two equations, and the goal is to eliminate just one variable. Okay, so if you take a look at these first two equations, 1 and 2, you'll notice that x is already opposite of each other. So if I were to add these equations right now together, those x's would cancel. So that's what I'm going to do. So I'm going to look at equations 1 and 2. I'm going to pick equations 1, and I'm going to pick equations 2. And I'm just going to rewrite them, and I'm going to add them together because I know that the x's, like I said, will cancel each other out if I were to add them right now. So I'm going to do that. I'm going to add these together. So x plus negative x is 0. Negative 2y plus 3y is going to be just 1y. 3z minus z is going to be a 2z. And then 9 plus negative 6 is going to end up being just 3. And then just stick that equal sign right below. This equation, we're going to call this equation 4, and we're going to come back to equation 4 in a second, but first step is done. I've combined two of the equations, and I've eliminated one of the variables. Now that I've eliminated x, I'm kind of stuck with eliminating x, so we're going to create one last equation. We're going to call that equation 5, but we're going to do that by picking another pair of these original equations. So I already used 1 and 2, so I can't use those two equations again, but I can use, for instance, 1 and 3, or I can use 2 and 3. Now I'm going to use 2 and 3. And the problem is I want to eliminate x, but equation 3 has a 2x. And right now, if I were to add this with this, I'm not going to have those cancel. So what I'm going to need to do, like other elimination problems, is I'm going to need to multiply number 2 by a number to get it to be opposite of 2x. So I'm going to start by writing out 2 and 3. So equation 2, equation 3. So that's negative x plus 3y minus z equals negative 6. And then 3 is going to be 2x minus 5y plus 5z equals 17. In order for, again, these to be opposites of each other, I would have to actually multiply this top equation. And I'm going to do that by multiplying it by 2, because that would get it to become negative 2. And when I add those together, it obviously will be opposite. So I'm going to multiply this and write this here below. So that's going to be negative 2x. 2 times this is going to be 6y, 2 times z is going to be negative 2z, and then 2 times negative 6 is going to be negative 12, okay? So I kind of rewrote 2 as this now by multiplying again everything by 2. And if you notice, if I add these together now, I'm going to get those x's to cancel. So I'm going to do that. This plus this is nothing. Negative 5 plus 6 is going to give me a y. And then 5 plus a negative 2 is going to give me a positive 3z. Drop down the equal sign. And then 17 plus negative 12 is just going to give me 5. Okay? And this is going to be what I like to call equation 5. So I have two new equations, equation 4 and equation 5. What's nice is, you'll notice, is that there are two of them, and they have just two variables. This is exactly the type of equation you were solving yesterday in the attendance task. So that's what we're going to do now. So we're going to take equations 4 and 5, and we're just going to solve for those two variables in those two equations. So y plus 2z equals 3, and then this equation 5 is y plus 3z equals 5. And again, we're going to use elimination one more time. So I just need these to be opposites, and it doesn't matter which variable I cancel first. The one I'm going to cancel is going to be y. I think it'll be a little bit easier. And in order to get them to be opposites of each other, I'm going to multiply the bottom one by negative 1, or I could do the top one too. Now, if I wanted to get the z's to be opposites, I would have to be a little bit trickier. I would have to multiply the top guy by probably 3 and the bottom one by 2 to get them to both to be 6, and then one of them would have to be negative. I could make one 6z and the other one negative 6z. That's another option too, but I think the easier way right now is to multiply this top one by -1 so that the y's become opposites. So I'm going to multiply this guy by -1, so multiply everything by -1. I'll rewrite that below. So negative y, negative 2z, drop down the equal sign, and -1 times 3 is -3. So that is that new look 4. I'm going to add that with 5. And when I do that, I'm going to end up getting nothing for y. I'm going to get, this is just going to end up being z, and then 5 minus 3, or 5 plus -3, is just going to end up 2. And that is the answer, at least for z. Now, to figure out what any of these other variables are, I'm going to have to plug in and get that. Now, I'm going to do this in stages. So I'm going to go back to either the 4th and 5th equation. I'm going to pick one of those to plug my z back into, but that's how I'm going to find y. But once I get y and z, I can then go back and get x. So let's start by getting y. So I'm going to pick, I'll just pick this 4th equation. I'm going to rewrite the 4th equation, but instead of writing z, I'm going to replace it with the number that it actually is equal to, which is 2. And I'm going to solve for y here. So y plus 4 equals 3. I'm going to solve by subtracting 4 from both sides, and I'll get -1. And that one's going to be what y equals. So now I got z and y. And now I just need to figure out what x is. So to figure out what x is, I'm going to go back to my original 3 equations. I'm going to pick one of those to plug y and z in, and then get x. So I'm just going to pick this first one. I'm going to rewrite it. X minus 2, but instead of y, I'm going to write in -1 plus 3z, but instead of z, I'm going to put 2 equals 9, and now I'm going to just solve for x. So let me do some dirty work real quick. -2 times -1 is a positive 2. 3 times 2 is a 6, and then that equals 9. I'm going to add these two like terms together. That gives me 8. And then subtract 8 from both sides, and I end up getting x equals 1. So my 3 answers to this problem is x equals 1, y equals -1, and z equals 2. And that is how you do a system of equation with 3 variables. All right, for the second example, why don't you try this one out? So why don't you pause the video, write this down, see if you guys can try it out. I'm going to give you a quick hint though. I started the problem out by eliminating y's and solving for x and z first, so that's the way I did it. But again, you don't have to do it that way. You could eliminate any one of these variables, but stick to one variable at a time. So once you pick the variable you want to eliminate first, pair those equations, come up with equations 4 and 5, and then solve it. So again, I did it by eliminating the y's first and solving for x and z, but it's up to you, but that is the way I'm going to show my work in a second. So pause the video, go ahead and see what you get. All right, so welcome back. Here goes the answer. So I started again by labeling these 1 through 3. I picked the first 2 because again, I was going to eliminate y. So I started by multiplying to get these y's to be opposites, multiplying the top guy by 3. So when I multiplied that top guy by 3, I ended up getting this. When I add these 2 together, the y's eliminate, and I end up with this 4th equation here, 9x minus 7z equals 2. Then I paired a different pair, and because you can't use the same pair twice, I paired 1 and 3 together, multiplied the top one by 2 because I wanted that y to become a positive 2, so I could add those y's and cancel them. So I multiplied this by 2 and ended up getting this, so I added those equations together. I got 5x, the y's canceled, ended up getting a -z, and then I got a 4. So my 2 equations, 4 and 5, were this. All right, now to get rid of one of these other equations, or another variable. So I ended up picking z. So in order to do that, I wanted to get these opposites, so I multiplied the bottom equation by -z, because that would make that a positive 7, and those would cancel. This is what I ended up getting when I multiplied the bottom by -7. Added those together, I got -26x. Z's canceled, I got a -26. Divided by -26, I got x equals 1. I then plugged 1 back into this top equation to get z. So z also equals 1. And then I plugged 1 and 1 for x and z into my original first equation. Here's my work down here. and I used that to solve for y, and y ended up being -1. So here's the second example. Hopefully that helps. In the attendance test today, you're going to be asked to try one of these out on your own, and we'll see how many of you guys, or how you guys are doing. If this looks completely out of left field from you and you need some extra help, I have office hours today from 1 to 2 and get you some extra help on these problems. You guys have a wonderful day.